Example number 2. Calculate the heat of fusion of ice when 9 grams of ice is placed in 51 grams of water at a temperature of 23 degrees Celsius. The final temperature of the solution was 16 degrees Celsius. Remember, in order to determine heat gained by the ice, two things happen. First, the ice melts when put into the warm water. Then once all of the ice has melted, the melted ice's temperature increases. Since we have a phase change and the temperature increases, two terms are needed in this equation for melting of the ice. These equations are negative heat lost by the water equals heat gained by the ice. Heat gained by the ice is defined by this equation. Delta heat fusion times mass of the ice plus specific heat of the water times mass of the ice times delta T, which is final temperature minus 0. Heat lost by water is defined by this equation. Negative specific heat of water times mass of water times the change in temperature of the water. Next, we have to combine these two equations. When we combine these two equations, we get negative heat lost by water equals heat gained by ice, which is defined by negative specific heat of water times mass of the water times the change in temperature in the water, which equals delta H heat of fusion times mass of the ice plus specific heat of the water times mass of the ice times change in temperature, which is final temperature minus initial temperature. Remember that. Also remember that final temperature of the solution is equal to the final temperature of water and the final temperature of ice. Our variables are as follows. Our specific heat for water is 4.184 joules per gram Celsius for the water and the ice. Our mass for the water is 51 grams and our mass for the ice is 9 grams. And our change in temperature for water is 16 degrees Celsius minus 23 degrees Celsius, giving us negative 7 degrees Celsius. And our change in temperature for the ice is 16 degrees Celsius minus 0 degrees Celsius, giving us 16 degrees Celsius. Now that we have defined both equations, we have to solve for heat of fusion using our newly found equation. So we plug in all our variables and we're going to solve to the right of our equal sign. From there, we obtain the number 1,493.688 joules. Next, we will be solving the part which is in the brackets. From that, we get 602.49 joules. We have to subtract this number from both sides, and this will give us a value of 891.19 joules. Next, to get heat of fusion alone, we will divide by 9 grams. And your heat of fusion should equal 99.02 joules per gram. Conversions. To convert the value from joules per gram to kilojoules per mole. Our given answer was in joules per gram, which was 99.02 joules per gram. There are 18 grams in every mole, and there's 1 kilojoule per 1,000 joules. So first we have to multiply 99.02 by 18 and then divide by 1,000 to give us a value of 1.78 kilojoules per mole. Next, we have to find our percent error. Percent error is defined by theoretical minus actual, all divided by theoretical times 100%. Our theoretical value was 6.01. Our actual value was 1.78. And we have a percent error of 70%.